Okay, so now we go through derivatives of logarithmic functions. That's the second one, right? We've gone through exponential, now we go through log. And we are only doing the natural logarithmic functions, okay? Which is exactly the opposite of what we've been doing. Now, that's what I actually need you to know before we do anything. It's just that if you have, if I say you have 7, right? If you get e to a function, e to the x, and get some value, right? If you then do ln of that, you are going to go back to 0. So let me do it. If I say e to the 7, then I say ln of this e to the 7, I'll go back to 7. It's like I've done nothing because ln and e are opposite. Or if I say ln 7 and I say e to the power of that, this is just 7. It's like you've done nothing. 7 comes down because e and ln are opposites. So 7 will come down as he is, right? ln of e, you whatever you are getting e, if you then do ln, it's like you've done nothing. So you're back to 7. E of ln is 7 again. It's nothing. You have done nothing. So that's the first thing to know. Now let's go ahead and find there are two derivatives of ln, just like for e we saw 2, okay? For e to the x, that it was equal, that when you differentiate you get e to the x, and then we saw for e to the f of x. We want to do the same. We want ln x and then we want ln f of x. So let's go ahead and let's do that, okay? So now let's see what happens. Yeah, and here's our first one. We would say y is equal to ln x, right? We want to find the derivative of ln x. We just want to see what it is. So this part you don't have to remember, okay? But we don't know what type of question comes in an exam. That's why it's nice to just know. So let's go and see. So what we are going to do is we're going to get exponentials both sides, okay? So step 1, we get exponentials both sides. We say e to the y is equal to e to the ln x, which means that e to the y, remember, when you say e and ln, you have done nothing. So it will be equal to x, just comes down. So we say e to the y is equal to x. That means we can go ahead and find the derivative. Let's find the derivative with respect to x. Okay, let's find the derivative with respect to x. Okay, so here I'm going to say d dx of this. Okay, let's do it on the next line. Okay, d dx of e to the y is equal to d dx of x. Now, what is the derivative of e to the y? When you differentiate e to the y, let's get it. Or let's find the derivative with respect to y. Sorry, let's say d dy, let's find the derivative with respect to y, is equal to d dy of x. What does that mean? D dy of e to the y, does it change? No, the derivative of e to the x is e to the x. Derivative of e to the y is e to the y, especially if we are doing with respect to y. Now, what is d dy of x? It is the derivative of x with respect to y. It is dx dy, okay? So now I have dx dy be equal to e to the y. But if I go back to this stage, e to the y is x. They are the same. So I can remove e to the y and put x. So I can say x is equal to dx dy, okay? Sorry for the mistake I did on that stage, but it's okay, you get it. Okay, so dx dy. Now, which means, are we interested in dx dy? No, we're interested in dy dx. So what I'm going to do, to find dy dx, I flip the right side. So it becomes dy dx. And I flip the left. X is the same as x over 1, right? When you flip it, you get 1 over x. So 1 over x is equal to dy dx. So I find it. Dy dx is what? 1 over x. So I have my solution that the derivative d dx of ln x is equal to 1 over x. Because what was my y? It was ln x, right? And what was my derivative? My dy dx, it was 1 over x. So with that, I can therefore put in the real bracket to say that the derivative of ln x is 1 over x. That's the first thing to know, that the derivative of ln x is 1 over x. Now let's go ahead and do the derivative of ln of something which is not x, like a 5x, a 2x, or whatever. Remember, we'll call those things f of x, right? So ln f of x, it means it will be something which is not x. Let's go ahead and let's do it, okay? So I'm now going to the next video and we'll do it in there.